Welcome to the Teardown Sessions. I am your host, Helen Leigh, and today we're going to be talking about all sorts of exciting things with Robin Reiter, who is the creator of Pixel Pump. If you've not seen Pixel Pump already, it is crowdfunding now as well. You will be able to, there's a fantastic pick and place machine that is a vacuum pump. We'll be talking in more detail with Robin about that creation and also his ideas for packaging and running print farms and all sorts of interesting things. But before we do that, I would like to share what's going on at Crowd Supply. Let me just share my screen here. What is going on at Crowd Supply? Let's add that in a second. Add you in here. Here we go. All right. So currently crowdfunding at Crowd Supply, we have got the fantastic bean counter went live very recently from Nick Poole from SparkFun. If you are a regular watcher of the stream, you'll know that I hosted Nick Poole the other day, a couple of weeks back, and we had a fantastic time talking about this project and design as well. So if you do anything with SMD stuff, this is a fantastic little device that will count your SMD cut tape reels. But there's also a really awesome feature of this, which is dispense mode. So if you are a kitter, I think this is an invaluable tool, and that's already massively smashed through its goal by nearly $10,000. So, but there's still 34 days left. So if you want to support Nick's work and get one of these, I'd hurry along there. Another thing that's live at the moment, only just gone live, is this AquaPing, which is an acoustic water leak detection. Pretty exciting little smart sensor there. So check that out. That is 48% funded, and it wants to reach $4,000. So if you want to support them, that would be great. Also live at the moment, we'll be learning a lot more about this over the course of the next hour, is the Pixel Pump. This is the beautiful thing. It's already hit its goal, smashed through. It is 168% funded with 18 days left, as no more than it deserves. I hope it does even more than that. So please check that out. And obviously, we'll be talking a lot more about this device over the next hour. I also wanted to draw your eye to a couple of things that are coming up soon. This is one that I particularly like. I came across this at the Portland Hardware Happy Hour, actually, and was like, you should definitely do a Crowd Supply campaign. Really awesome little device here that you add on. So this guy has reverse engineered the Pocket Operator range of little noise machines from Teenage Engineering. Fantastic company. Everyone admires their lovely little boards. But this is an add-on that allows you to play any of their instruments like a maraca. So it's got a little accelerometer in it, and you can play it by moving. Really fun little device. Would highly recommend you sign up to notifications. That's going to come soon. And finally, I wanted to give a shout out to PlaneDAC, who are launching very soon. And they've just done a big redesign of their board based on a bunch of community feedback, and it's looking delicious. So go on along. And if you've got a use for a PlaneDAC module, go on along and check that out. That's coming soon as well. All right, so that's what's going on with Crowd Supply. Let's remove that. And before I bring Robin on, of course, I need to tell you the rules. For every week, we give away a box of mystery hardware, which everybody loves. It comes in a very fancy little sandwich tin. And inside of this box, there's usually swag and at least one piece of hardware for you to play with for free. So the way that you win this is by commenting or asking questions. And the comment or question that comes the closest to the timestamp that I've written down on a piece of paper in front of me will win the box of mystery hardware. So if you would like to win it, please just keep your comments and questions coming in. And I do hope you do ask us questions and comments, because it does make us feel a little bit less like we're alone and shouting into the void. Although I do say there's quite a few of you who have joined us already, which is great. Okay, let's bring on Robin without further ado. Let's change this over here, add it in. Hello, Robin. Nice to see you.
Hey, thanks for having me.
Of course, it's a delight. Please tell me who you are and what project it is that you're working on.
Yeah, well, my name's Robin. I'm from Germany, from the very southern tip of Germany. And I'm actually doing all kinds of things. I'm working as a software developer, but I'm also enjoying, electronics and hardware and just making things. And my recent project is the Pixel Pump and everything that's kind of part of it. Yeah, like who would have guessed? so there's the pixel pump, there's the SMD magazines, there's injection molding, there's packaging, there's like all sorts of things, and those things make it interesting to me. So I really enjoy working on the project.
How long have you been working on the pixel pump? Because it's been I've seen you do like multiple rounds of prototyping on Twitter. And for those of you that don't follow Robin on Twitter, you should go along and follow him immediately, because he's one of the makers of the ilk that builds out in the open. There's also always lots of really interesting things on your Twitter feed. Very much enjoy that. So thank you for sharing your learning.
Oh, absolutely.
As you go.
Yeah, Twitter is kind of my main outlet for just doing stuff, and I try to post the interesting things I do all day long in my shop or elsewhere. And yeah, if you're interested in work in progress stuff or so, then I guess Twitter is probably the best place to go.
I mean, who isn't? Let me just I will add the little that's the Twitter handle right there. There we go. So all good. All right. So tell us a bit. I'll bring up Pixel Pump. Walk us through it a little bit. Like, what was it for? What do we do with this thing? What do we do with this device?
Well, yeah, it's kind of like, in a nutshell, it's a vacuum pump for your desktop. It's pretty small and compact, so you can have it on your desk and don't have to stow it away if you don't need it. It's basically meant to do small scale production runs or prototyping, like PCBs, or I have an automated pick and place machine. And I still use the pixel pump for some components, because there are some components not compatible with automatic machines, but there are, because of the shortage, you just don't get them. But there are components made for hand placing which go with the pixel pump or work with the pixel pump and not with the automated machine. So I'm still kind of using the pixel pump even though I'm running with an automated machine. So it's kind of just something in your tool belt if you do PCBs and prototypes, and that eases up, like, picking and placing on PCBs by hand.
Is this the first product you've made? Like, is this?
Yeah, that's my first personal, like, commercial product I've made. I have been working as an injection mold designer for a company a few years back.
Okay.
But I haven't actually made a product from like A to Z. And the cool thing about the pixel pump is I was doing the, hardware design, software design, PCBs, all those things. And I learned so much, and I really enjoy, like, working on all those disciplines, not just on the software side or the hardware side.
Full stack.
Yeah, it's kind of full stack. Yeah, basically.
Project full stack.
Yeah, project full stack. And yeah, the pixel pump also comes with the SMD magazines, which are just some containers to put your SMD tapes in.
Are these custom?
Yes.
Okay.
Yeah.
And these are designed for you specifically with
that's actually how it started.
Oh, really? This is a big project. Yeah. Like, for somebody's first product, I mean, it's complicated. There's several parts to it. It's a beast of a device.
Basically, I mean, I started, I'd say 2 or 2.5 years ago with the SMD magazine. That was kind of the start, because I was doing PCBs by hand, and I just, who doesn't hate the plastic bags with the strips in it, because you don't find anything, because you have a big box with all those components. I thought there must be a better way, and kind of that's where the SMD magazine started. And then I thought, okay, the magazines are cool for storage, but you need some way to consume them. So I made this little rail to have them all, in one place.
Spotlight you so you can.
It's hard to see maybe, but there's this rail here where you can just add the magazine. So the basic idea is you have your collection of components stored in the magazines, and just depending on the project you're working on, you can take the ones you need from the shelf, put them onto the rail, have them on your desk, and just start picking and placing. And that's kind of the idea. Because I have started collecting components from various projects. So I have a couple of those here. Just, I just throw them in here because nothing's going to come loose. And it's a lot easier and quicker to find the ones you need if they're not in those bags.
So that was your original design. And how did you originally manufacture that? Was it like a 3D printed situation? Because you're going to be injection molding these, right?
Yes.
So tell me about the design process for these original magazines.
This is the second version, actually. The first version is on Thingiverse, and people could download them and 3D print them, the first version, to see if that even is a product that might suit them. The version 2 obviously has a few modifications that come in handy in my mind, especially like the front is spring-loaded, meaning you can load different tape heights. So you have the standard paper tape, you have whatever SOT 23s in plastic tapes. They're all different thicknesses. And with the old magazines, you have to print the exact thickness you need. And this one has a spring-loaded lever to kind of hold all thicknesses, basically, up to, I think, 9.5 millimeters. And it's not only...
Go on.
What's that?
Yeah. No, go on.
It's just one other benefit of having the spring is that it's going to hold your tape firmly, so it's not going to flip it around. Yeah, that's kind of the main benefit.
That's really awesome. So I've got a couple of questions here from people. So Newgard, hi, thanks for joining us. The SMT magazines are really cool. Are you selling those separately? Are you selling them separately?
Absolutely. I mean, you can head over to the crowd supply campaign of the Pixel Pump and just go for a bunch of magazines. You don't have to buy the Pixel Pump. If you have a solution for that, for like having a vacuum tool, just go for the magazines.
Okay. And then Salman says, is it all 3D printable? I mean, the SMT magazines. Hi, Salman. Thanks for joining us. Salman, I believe, is on the board of the Open Source Hardware Association, if I remember that correctly. Yes. Yeah. So the V1 is all 3D printable, but V2 with the spring-loaded one is not. Interesting.
Well, those ones here are 3D printed. Those are prototypes, and those are the ones that I sold with the beta units of the Pixel Pump and beta testers. And I have actually I had my web shop open quite a few months ago where you could just have ordered those, and they were 3D printed. I don't really see a drawback in having a 3D printed version of this. Works just fine. So yeah. But those are being 3D injection molded because I want to get them cheaper over time, and I cannot 3D print them. It's like 2 print hours for one magazine. It's not.
Yeah,
really,
I was going to say. Yeah, I mean, how did you? So when you were originally prototyping and selling the early versions of these SMT magazines, you were printing these all yourself, or you were farming them out to somebody else? So you're printing them in your own workshop.
Yeah, absolutely.
And how did you did you have like a print farm setup? Like, what was the deal?
Yeah, I had one Prusa Mini. Or no, actually, it's not true. I started with a friend of mine.
Just there.
Yeah, it's a lovely printer.
I love it. Yeah.
A friend of mine, some of you might know him as CNC Kitchen. He's also doing YouTube videos about 3D printing, and I actually know him. And he's a friend of mine. He lives right next to me, basically. And he had a bunch of printers, like random printers. Like there's an i3 Mega, and so he didn't need. I asked him if I could just rent them from him to have a print farm just immediately, And I started printing SMT magazines with those. And then I bought the first Prusa Mini and then the second Prusa Mini. And I think right now I'm at 10 Prusa Minis.
10 Prusa Minis.
Yeah.
And there I was thinking I was ridiculous for having 2. Like 10 of them, amazing. And so you use those 10 Prusa Minis as an actual print farm. So what kind of like throughput were you getting? And were you doing... Because I've seen in other people's print farms, there's like modifications to like push things off of the shelf and like continuously print. Like what did you do, and what was your?
Basically, the thing is, I'm not sure like how many printers I would need. So the more modifications I have to make to a printer, the more printers I have, the more modifications I have to do. So I basically try to stay out of the box as far as I can, because it's a lot easier to scale if you have some mod that takes how many hours to complete. You have to do that times 10 if you need 10 printers. So I'm not seeing, like with the magazines, I think the belt printers might have been pretty handy.
Yeah, I was going to say, if you wondered if you considered that.
Yeah.
I've actually not used one of the new belt printers.
I have never used them. Never used them. But the thing is, I have my workshop right next to my office. So I have 2 magazines on one build plate. So it takes 4 hours for them to complete. And I just don't see why taking them off and restarting the printer is so much worse than having a belt, Like, where's how many hundreds or thousands do you have to make until that's gonna,
Yeah, I suppose you have to. I guess it cuts into productivity time if in the evening. So if you're taking two hours to print each one, and you've got 10 printers going, every 2 hours you have to remember. But like overnight, if you had some kind of system to push them off the belt, or
you're right.
It could go 24 hours with no human intervention.
Yeah, well, but the only thing is, like, the print farm, I think I'm changing every week. I'm changing like 4 or 5 nozzles. I'm pretty sure those would,
Oh, really?
yeah, I'm really sure those
Every week?
failures. Yeah, because like the nozzle is a €2, spare part,
Mm.
and if I investigate 2 hours why the printer is not working, or just swap the nozzle for €2, that's kind of
You're
yeah
saving your
the
own
thing.
time,
Yeah,
which is
and,
worth more than $2, that's for sure.
and I was scared at the beginning of maintaining the print farm and stuff, but
Mm.
those are like the 2 or 3 things you have to do constantly, is like change nozzle or do stuff like that. You get routine with that. It's not a big deal anymore. You change the nozzle in 2 minutes without even looking up the documentation or so. It's not a big deal. And
Yeah.
so I just have 10 or 20 nozzles there all the time, where I just swap them out and that's it.
Okay, that's
Yeah.
a good tip. That's a great tip. And how many were you able to? Because how many did you sell that were 3D printable? Like, did you do like a quite limited run, or
No, I think, I don't know, maybe 500 or so.
so you did or 500 by hand? That's actually a lot.
Yeah. Yeah, but we were like, my dad was running the print farm, because he retired and he got bored, and I said, look, let's try that. If you want to do that, we can certainly put the 3D printers in your house. And he was like super thrilled about it. And yeah, he's 74 and he's having a great time running the printers.
Yeah, I
Um,
think my dad would like that as well, actually.
yeah,
Yeah, for sure. That's really awesome. All right,
yeah,
so I've got a little compliment here from John Jackson saying that you've got a system-level attention to detail. I believe that was referring to the spring-loaded SMT magazines, which I agree with. And then Twinkle Twinkie, hello, awesome. Nice to see you here. Thank you for joining us. Says, proves to me are very reliable, accurate. And also asks, why not use a nozzle that isn't brass? So you're using brass nozzles all of
yeah,
this. I mean,
yeah.
yeah.
Well, thanks for the kind words. Actually, it's very nice to hear that. The thing is, I think most of the time the nozzle I have to change a nozzle is not because of the material, but because it is clogged. And I think you can clog, any kind of nozzle, with the dirt on the material, or just stuff like that. I don't think a non-copper or non-brass nozzle is going to save you from that, I guess.
Okay.
And I'm not doing any abrasive materials. It's all the magazines were PLA, but the pump and the rail is PETG. Yeah, so actually, I see the question with the thermal conductivity, and that is
Yeah.
true. But the thing is, I'm having Extruder is the brand, and it's PETG metallic, and they have little like metal flakes in it, and you print it at a lot lower temperature because it's a lot more thermally conductive. So I think that kind of compensates for if you had a different nozzle. I think the material would still be fine.
That's interesting. Very cool. All right, so you're moving on to, I'd actually like to talk to you a little bit about your industrial design. So we've talked a little bit about the SMD design and the fact that you're moving now from print farming and 3D printing, all of these different SMD magazines. But I know as well, so but you're flipping over to injection molding, right?
Yeah.
After the
Mm-hmm.
campaign. So what's the design process? Is it very different, like in terms of the design file that you have to provide?
Yeah, that's a good question. The thing is, you have absolutely 2 different sets of design constraints. Like with injection molding, you could do things that are not possible with 3D printing, and vice versa, basically. You have to have draft angles for injection molding, which you don't need for 3D printing, but you cannot have overhangs in 3D printing, or you can, but you have to have support material, and yeah, that's kind of messy. But yeah, you have like pros and cons for every. So basically, the design file will stay the same for me internally. I just add the features or mods that I need for injection molding. But yes, you certainly have to, and that's the thing with the 3D printing or injection molding or just CAD in general. You have to kind of know your design constraints because you will have them always, right? You have to use the screws you have maybe, or you're limited to a certain set of materials, or you have a 3D printer that is a 0.6 millimeter nozzle, or you always have those design constraints, and that makes it interesting if you ask me. So you have to figure out how to design that without an overhang, or how to design that so that the draft angle is not a problem. that's kind of making the thing interesting.
But I mean, have you done a lot of design for injection molding before, or has this been a learning experience for you?
I have not done a lot. I have once made or designed an injection mold itself, but not 100% complete. It was like I got assistance for the cooling, because you have to have the cooling paths for the water, and so I would certainly not call me like experienced in that field. I think I have a just a feeling for how it should be, and I have a really cool guy with the shop in my town here that has
ask if you've got help.
yeah, sure. I mean, like, it's not a bad thing to ask for help, right?
No, it's a positive thing. Absolutely.
Yeah, absolutely.
Because to me, like, I mean, designing for 3D printing, the iterative process is so if you mess it up, if your design doesn't work, like it's not that big a deal. You just tweak it and you move on again. But with injection molding, like that is a big deal. You're spending a lot of money, and if you get something wrong, like it's on you.
Absolutely. And you want to have your design reviewed by someone who is actually experienced in that field. And the guy who runs the shop here, he has the injection molding machines that make the actual parts, and also those CNC machines to make the molds. So he's kind of knows, what's possible and whatnot. And he's actually, he reviews my design and says, look, you have to have your draft angle differently here or something like that. And I think I can trust him when he says, okay, look, this design is going to work. Then I'm sure it's going to work, I guess.
So you've got someone you can lean on. That's fantastic.
Yeah.
I've got a question here from Nugar saying, did you have to do a lot of iterations and modifications on the molds before you were happy with the result? Well, I think this also assumes that you are happy with your current result. Are you?
Yeah, but I have not seen a magazine from the injection mold, so I cannot really.
Is it done? Is the design, are you finished, or are you still tweaking?
I'm still doing the last tweaks. Actually wanted to send it today, but I'll do it on Monday because I haven't really finished it.
So nearly. Yeah. So has there been, a lot of big changes over the course of the period of time?
Actually not. And I was sitting at my design and I thought about, look, the magazines are out there since 2 years or so. And I didn't even think of one thing that I would have to change on the design that kind of bothered me while using them. And I made a lot of boards with them. And I cannot remember a single thing that I should change. So I don't know. I think it's cool as they are, I guess.
That's fantastic.
Yeah.
That must feel good. I mean, yeah. Are you nervous about sending it off? Because here we are. Look, so Twinkle Twinkie here. This is good context. For those of you that don't know about injection molding, it is also an extremely expensive process to get the mold made. That is the actual devices after the mold is made cost almost nothing, but making the mold is incredibly expensive. So as Twinkle Twinkie says, it's like about $10,000 to get a mold made in the US. Which Newcastle says enough to buy 10 3D printers, which is which you already have. So this amount is a lot of money. Is it nerve-wracking for you to send off something to injection molding for the first time, or you trust your design?
It is absolutely nerve-wracking, of course, because you can always do certain tweaks. For example, that's one interesting fact. Maybe it's a compliant mechanism, right? You have the lever here, which is just there's no spring here. There's only a bridge, a plastic bridge. Can I just?
I'm gonna solo you 1 second.
Can you see that between?
Yeah. Oh, I see. Yeah.
Kind of the spring.
Yeah.
And that's how the magazine actually attaches to the rail. It is you insert it here and just push it down. And then it's inserted, and it's actually pretty stiff, so there's no wobble, nothing. And here's the thing with injection molds: I will design that bridge here to be thinner because you can open up the mold later on, but you cannot make it thinner, right? You cannot add material to the mold, but you can actually go in with the CNC and open up the gap a little bit. So I start thin and go towards the correct stiffness, And that's one way you can actually, or you are still a little bit flexible with injection molds. It's not an entirely one-off thing.
I see. I didn't know that actually about it. I have been to a couple of injection molding. I spent a bit of time in Shenzhen a couple of years back and got to go and see some injection molding factories, and they're really fascinating places. Where are you going to get yours done? In China or?
Oh no, in Germany.
Oh, you're getting them molded in Germany. Oh, interesting.
Yeah, it's basically like 10 kilometers from my place.
That's fantastic. How is the price differential?
I I haven't even got a quote from China, to be honest.
Oh, really?
No, I did not.
Fascinating.
Yeah, I
And you,
wanted to do that in Germany just
yeah,
because I really like the person who runs the shop. I didn't know him
yeah.
before. It was like it started with this project, but he's really a nice person, a very very experienced person, and I
Mm,
trust him. And I don't want
yeah,
to have designs sent to China and they don't work, and then I have to recommunicate. I think it just takes too long.
yeah,
And
yeah.
long story, like long run, I would like to have my own injection molding machine and make the magazines in my own shop.
Oh,
That's
you're
kind
one
of
of those makers. I see.
oh yeah, I yeah,
Like,
it's ridiculous sometimes, but I just
yeah.
love vertical integration and I love doing as much as I can by myself because it's interesting.
Define vertical integration here for those people who are watching who don't know what you
Yeah.
mean. So,
So basically, I think the easiest example is I don't buy my PCBs PCBA assembled. I just buy the bare PCBs and then assemble them on my own with an automated machine. And you have to really want to do that because it's a lot of overhead in terms of time, and also
yeah.
it's going to be more expensive, obviously. But
And you've
it's
got
a
to
lot more
have the
fun.
space.
You gotta have this. Yeah, you have to have
Yeah.
everything. Like it has so many downsides, but
Yeah,
it's a
yeah.
lot more interesting for me personally. And also, I'm
Especially you get to
learning.
press go on a pick and place machine. Who doesn't love doing that?
Yeah,
Like,
I mean,
like,
yeah,
so fun to use them.
it is fun to use them, and you learn a lot. You learn how feeders work. You learn how to design your PCB so it is better manufacturable because you're the manufacturer actually, and you learn a lot of things. And I also learned a lot of, I have a Swiss machine. It's 20 years old, the pick and place machine I bought,
Mm-hmm.
and it's just, it's built like a tank. It has such a nice, linear rails, and you just learn a lot by just looking at the machine. And yeah, I don't know. I was since a kid. I wanted to do the things on my own, and it kind of just kept going like that. So even if it's financially not always it doesn't always make sense, but it's more
It makes
interesting.
sense for your own learning as well, though.
Yeah.
You know. That's really interesting that you're doing injection molding in Germany. Actually, do you know, like quite a few of them are German creators do their manufacturing in Germany as opposed to China. I mean, Germany's got quite a lot of manufacturing capability though as well, and it's very high quality.
It's also very high labor.
Yes,
that's kind of the problem. But the thing is,
it's true.
Running injection molding machines is not very labor intensive. You get a lot of products for not so much labor. You don't want to have your product assembled in Germany, I guess, except you have a product that's 100,000 euros or so. But you certainly don't want to have the pixel pump assembled by some contractor in Germany. I guess it just it wouldn't pay off, I guess. But running injection molding machines or things like that who are not so labor intensive makes sense. At least
I'd be very curious to know how much they charge you for the die and then for subsequent pieces. I mean, I imagine keeping an eye on your Twitter, you might share that information at some point.
I think I have already shared it. I think the mold is somewhere around 7k euros or 8k for the magazines.
That's what I was expecting, to be perfectly honest with you.
It's
that's
not
quite reasonable.
Yeah, well, it's an aluminium mold. It kind of lasts for 50,000 magazines or so. Then you have to make a new mold.
Yeah. Interesting. I've been chatting too much. I've not given you any of these questions and comments that have been. I'm also a bit of a nerd about tools and process, so I really enjoy like going to factories and learning about different. So I totally relate with you here.
Yeah.
All right. So comments here from Uli Flynn saying, "I really like the SMD magazine since you can have a library of components at your disposal." I fully agree.
Yeah.
I fully agree.
That's the
Bruce thing as well. Bruce Segal has asked a question. Any reason you didn't do it as a DIN rail mount? I bet you've got an answer for this.
Yes, it's a great question, and I get that asked a lot. And I actually made experiments with it. And the problem is, DIN rail is a great product, but it's for a different purpose. So a DIN rail is not meant to be, it's meant to be in an electronics cabinet or so where you don't always change stuff on it. So it's not made for rapid, iterations or for unmounting and mounting devices all the time. It's just not made for that. It's made because, where I have to start somewhere else, I guess. The thing is, the first downside is it's only that wide. It's like 3 centimeters or so, and the narrower you go, the more wobble you have in this direction. So that's the one downside. This one here is a lot thicker than the DIN rail. That's the one benefit. And the other one is the din rail is you cannot have a plastic hook it onto a metal din rail because it's going to wear off very quickly. And also the mechanism for every single magazine will be a lot more expensive because you need a metal hook with a separate spring. It just, there's a couple of reasons where it doesn't make sense to have a din rail for it. There are modifications on Thingiverse from my version 1, I believe, for din rail, but they're cool, but I don't think they'll last that long, to be honest.
So if you want to 3D print your own din rail PCB SMD magazine, you actually can go along to Robin's Thingiverse and do it yourself.
Yeah.
But that's very interesting. And Twinkle Twinkie says, who doesn't want to be their own PCBA? Yes.
Couldn't agree more.
Who doesn't want to do that, for sure?
Yeah.
I'm going to take a couple of the injection molding questions before I move on to Salman's question about RP2040, because I do want to talk about your microcontroller choice and your choice of language.
Yeah.
But we'll come back to that question before. So let's move on to Leon and Avi. Hello, Leon. Always great to see you here, and also a creator of some awesome open hardware. Saying Germany is quite famous with the traditions for injection molding. As far as I know, a few years back, someone's there started making Commodore 64 cases using the original molds from back in the days. That's wild.
That's really wild.
That's really cool, with the original molds as well, that they're still out there and still usable. That's pretty cool.
I mean, you need a pretty big machine to do a case like that.
Yeah, for real. And Bruce replied after his question about the DIN rail. So true about the DIN rail reasons. I've printed many DIN rail cases, but not for many mount-unmount cycles.
That is one of the major things that I was concerned about, because I had DIN rail. Was my first thought also to have a DIN rail, but that was one of my major concerns with this type of product on the DIN rail.
Yeah, because you're taking things on and off quite often. Yeah. Really interesting. So we talked a lot about the SMD magazines here, but are we doing the injection molding for the Pixel Pump with the same company? So there's a little question here from Bruce saying, isn't the Pixel Pump all 3D printer? But that was the previous version, right? You're planning for next version. The body of the Pixel Pump will also be injection molded, or
no. And there's also a couple of reasons for it not to be injection molded. But just to come back to Bruce, yes, the Pixel Pump is 3D printed, but we were talking about the SMD magazines, which are going to be like every SMD magazine you back on the crowd supply campaign will be injection molded. So yeah. But the Pixel Pump will stay 3D printed. There's a good reason for it, and we have talked about that before. And that was like change management. There are so many things that I change constantly. I'm running rolling updates all the time. Like I assemble a Pixel Pump and I see, okay, look, this screw hole has to be 2 millimeters to the left or so. I'm changing stuff all the time, and every serial number for every Pixel Pump gets kind of a snapshot from the current design. Meaning, I store which PCB revisions. Which Fusion 360 version. So if you come back in 5 years and you need a spare part for your serial number, you can have the exact part printed from that version in that time. And I don't have to have a warehouse for spare parts because I can print them on demand, like based on your serial number, or you just do it yourself. And that's kind of the reason, because things are changing all the time. Like we are in a shortage. If I don't find the magnets anymore that I'm using for the handle or so, what do I do? Change the injection mold? So that's why I want to keep 3D printing them. And also, we were talking about pricing. Like the injection molds for that, it's not going to be 7K. You need at least 5 or injection molds for the pump, and each 10K, 15K. So how many Pixel Pumps do you have to sell until you break even? And you're breaking even pretty quickly with the 3D printer. If you need 100,000 Pixel Pumps, sure, go and injection mold them. But if you need, 500 or so, there's no way around 3D printing. And the cool thing is, you cannot 3D print every product. Imagine you bought a Samsung TV or so, and the remote control was 3D printed. You would have the impression of a bad quality because it's rough edges, and no one would expect a 3D printed remote control with the television. But in this field, I guess, it's different. So yeah, I wanted to start, and starting the Pixel Pump without funding for injection molds is basically impossible if you want to do that. So it started with 3D printing, then I loved it, and now I want to keep it.
That makes total sense. Salman's asked what the main motivation is to move from a 3D printed magazine to an injection molded one. Twinkle Twinkies said possibly just ultimately cheaper or faster in quantities, but I wonder what you have to say about that. Like why you moved for the magazines.
Yeah, exactly.
Yeah.
So the one downside with having 3D printers is they don't scale. So if you need more printers, but your parts are not getting cheaper. If you need 100,000 magazines from injection molds, it's going to be cheaper than if you need 1,000 magazines, for example, because it scales, because they can have larger molds or just run the machine 24 hours a day. But with printers, it's not scaling at all. But the benefit of printers is that you have a very low entry cost. So that's going to cross somewhere, that graph, right? And if you cross the line, you're going to have injection molding machines that make cheaper parts. But if you are starting off or just need 100, you're certainly cheaper with buying 2 3D printers instead of an injection mold. So the magazines are kind of crossing that line right now. I have done a few hundred, and it's just better to have them injection molded.
Yeah, I can see that. I can see that. And Leon's piped up and said another advantage of open source design and 3D printing, which is the approach you're taking with the actual pixel pump unit, is that users can maintain the device over time on their own and 3D print spare parts. So that reduces the burden on you to maintain the project.
And it's not only that, they can also add stuff to it. Like the pump has expansion ports on the inside on the PCB, so you can add your own PCB. There are screw holes on the inside which are unused, so you can add your own PCB to the pump if you want to extend it, some functionality. And then you might need a new, right side or a back plate or something, and you can just take the files, modify them, and 3D print them. That's a cool thing.
I feel like that might be a good cue to move on to talking a little bit about the PCB and the possibilities. So I'm going to skip back to Salman's question from before, which was how was the experience working with RP2040 in a product? What were the advantages? I mean, aside from the fact you can actually buy an RP2040, is that like the right? You can get them, but yeah, I'd be interested to hear a little bit about your PCB design. And you said that it was very upgradable. Tell me a bit about your board.
Yeah. Do I have one here? Yeah, I have one. Just give me 1 second.
Yeah, of course.
So this is the main board. I mean, I'm pretty far from the camera, but I hope you can see that a little bit. Yeah.
Yeah.
So there's all the connections and stuff, and there's 2 JST connectors on there, one 6-pin and one 4-pin, which is meant to add accessories to the pump. So you could basically add Wi-Fi to it because it doesn't have Wi-Fi, or whatever you like. And the cool thing is the pump's vacuum system allows it to also make an overpressure and not just a vacuum. So therefore, you might be able to mod it into a solder paste dispenser, or just use it as a vacuum or pressure source, which you want to control with your own board or your own code, so that's why it has the expansion ports.
That's really awesome. Has anyone actually done anything with that yet? Because I know that, obviously we're doing the campaign right now, but I know that you did sell some advanced beta units.
Yeah.
Have you seen anyone make their own add-ons while it's been out in the wild?
Actually not, no. But but I think there's no documentation whatsoever right now, publicly available. I would certainly assist people to do mods, but I haven't had any requests. The thing is, they were contributing to the project in terms of like testing and software. So that's why it was super crucial to have the beta units out of the door very early on.
It's a really good idea. I actually recommend the approach of having a limited run of beta units before a real product it's really good advice, particularly with a complicated project like yours is. You've got many big parts, right? This is not like a dev board and that's done. This is an actual tool. It's a product, so
absolutely
having a beta run, I think, is essential.
I wanted to make sure that it's not just the bubble that I'm sitting in and liking the device. I wanted to see what people tell about it, and that was the main reason, to test it out, to give feedback, and that
How many
really.
Did you send out in the end?
I think 25 or so, 20 over the last year. Yeah. But to come back to the question, actually.
Back to the question, I was going to say, sorry.
I started with an STM32, And
you did?
Yes, and that was just where the chip shortage started.
Mm.
And prices were going up, and I was thinking about buying dev boards and unsoldering the MCUs as everybody did at the beginning. And I just didn't see myself doing that because it's not sustainable. Whereas you cannot just make a supply chain based on dev boards, which is not really good. And that was also the day, basically, or the week where the RP 2040 was announced. And I actually had Eben or Eben Upton
Yeah.
getting a little attention to the Pixel Pump project. We had a little chat with together, and
Oh, really?
he kind of introduced me to a few guys of Raspberry Pi, and we were talking about the RP 2040, and they gave me great advice with the hardware design guides and all that. So I immediately fell in love with it because the state machine that's on there, which kind of offloads all the LED, logic and stuff, it's just a great controller, and it's available, and it's relatively cheap. So yeah, I don't see myself
cheap, and you like it.
That's
excellent.
I don't see myself using any different controller
Really?
for
That's
stuff
fantastic.
like that.
So now you've used it, you wouldn't go back to an STM32, even if they came and showered you with chips.
No
Okay,
way. No, I wouldn't do that.
That's definitely a vote of confidence in the RP 2040. That's really awesome. And there's a follow-up question here, because this is an interesting one. Someone said, what code language did you use? And I definitely wanted to talk to you about this, because you're using MicroPython, aren't you?
Yes.
Tell me a little bit about your decisions here, and why are you using MicroPython, and the challenges. I'm actually quite a big fan of using Python on hardware myself. So I'm curious. I know, I'm a big
fan. Actually, one of the main reasons is that I'm just not comfortable in writing perfect C++ code. It's not my domain. Because I'm a web developer in my day job, I'm also confronted with Python from time to time. So it just kind of felt natural for me to use Python for it. And people were, complaining about the choice to use MicroPython for a finished commercial product because it doesn't seem to sound or seem right. But I think that's completely ridiculous, because I think the main thing is to get done. And I was taking 2 weeks until I had the C++ code on the STM32 running and displaying the pixel lights on the buttons and stuff. And I had 2 or 3 days writing the entire code for the entire thing in MicroPython. So why on earth would I not choose MicroPython? And also, I think it lowers the entry barrier for contributions of people. I think a lot more people will be able to contribute or hack it, or
I think that's a really good point, actually, because MicroPython, for people who aren't C++ developers, is a lot more readable. And one of the things I like to think about when I think about code being open as well is the people, when it's readable, people who don't have an intimate knowledge of the code base can just tinker with it by changing variables, because they can kind of see what's going on. So you're definitely opening it up to a bunch of people who wouldn't be able to tinker with it in C++. I think that's a really
absolutely
good point.
And you're also not locking yourself in, because you can actually use C++ code with MicroPython. You can write your own interface for some special class that you have in C++ and use it in MicroPython. So you're not actually locking yourself in. And there are projects, of course, and the main argument always is C++ is that much faster than MicroPython because it's actually compiled and whatever, What product are you developing? Are you making, some real-time whatever? Then just go with C++, no problem. But there are so many projects, including the Pixel Pump, which are perfectly fine to do in MicroPython. So,
Well, a follow-up question here from New Guard saying, I think a concern with MicroPython is a fear of limited libraries that restrict the use case. But I think that fear is slightly outdated, because there's been a lot of investment by a number of different organizations into MicroPython, actually, while I say that. So if you want to continue talking about MicroPython, I want to bring up a link, because the guy, Damien, who is the main developer behind MicroPython, he's actually at the moment requesting GitHub sponsors to use. So if people out there are using MicroPython in their day-to-day work, he's currently fundraising. So I don't want to put a little shout out there for Damien and MicroPython. So if you've got a few spare dollars and you use MicroPython a lot, you can go along to Damien and MicroPython's GitHub sponsors account and
I will certainly do that. I will certainly do that, because my project would not be possible without him, and without his project. And the one thing with the libraries is I never understood why we have CircuitPython and MicroPython. I understand that they had reasons to fork it and add their own stuff, but it would be so much better if all the power of those people would be consolidated into one thing, right? So we have libraries for CircuitPython and some for MicroPython, and they're not always compatible. So it's a waste. It would be so much better if they would just consolidate and extend one thing and not two.
Yeah, but they have different. I mean, the thing is, for CircuitPython, it's less. So MicroPython is more aimed at people like you, but CircuitPython is more aimed. I mean, it's mainly sponsored by Adafruit CircuitPython, and it's very much a language designed for learning, I think. Well, that's what they say anyway. But I agree. Here we are. I'm going to add in. Wait 1 second. Here is the. Hopefully, you should be able to see. No, I've shared the wrong thing. Hang on 1 second. Stop screen. But yeah, I wanted to share Damien's GitHub window. Here we go. That's it. So this is Damien's MicroPython sponsorship at the moment. So he wants to raise 10,000 a month, and he's about halfway there. In order to advance MicroPython. So that's github.com/sponsors/MicroPython. So there's 117 people doing it. That's pretty cool. So yeah, there's 2 people there who want to make a living and start being more focused on MicroPython. So there we are. Little shout out there to that.
Very well deserved.
Yeah, absolutely. So thank you, Damien, for your work. We hope you get to your goal for sure.
Yeah.
I've got more questions here, so I'm curious to know how you're planning to flash. I love hearing how people flash. And did you design any jigs yet? Would like to see that. Everybody likes the jigs. Nobody doesn't, No.
Yeah, who doesn't, right? I haven't made a jig yet, but the board, this is the release candidate, I think, and it has all the pins on the bottom, which are then used by the jig and to automatically test every board. Right now, I'm just using the capabilities of the Raspberry Pi, which is enumerating as USB flash storage. So I plug it in, press a button, and I have a USB storage. I just copy paste the firmware file to there, and it's gonna flash. And that's just state of the art, if you ask me. It's independent of your computer, of your operating system. You just plug it in. If your computer can read a USB stick, you can update the Pixel Pump. You just plug it in, and it's a USB stick. You don't have to have any tool or any driver or something like that. And that's the magic of MicroPython and Raspberry Pi, like the RP2040, or many of them are doing that. But
true.
I just love that.
Got a question here from Leon saying, do you plan to certify Pixel Pump at the Open Source Hardware Association directory?
Honestly, I haven't looked at that in detail.
Pretty quick. It's only a few forms. Actually, I find it very useful. I actually go to that. I go to the directory to learn what other people's licenses are. So, like, for example, I was like, oh, I wonder what the Beagle, like I was doing something on some work on a Beagle board, and I didn't know what the license was for the hardware. So I just went along and I went, oh, they've released it under this, like, I can't remember what it was off the top of my head, but it was useful for me to be able to go along and to learn what, like, license it was released under. And then, like, all the files are just right there as well. As a consumer, I find it useful. But yeah,
absolutely. I learned a lot from looking at schematics and designs and stuff, and I certainly want to bring that back because I think it's very valuable for the community for other people to bring up their own designs, of course. So I look into that.
All right. And Twinkle Twinkie says there are few things more satisfying to design and use than jigs. This is true. They're delightful. And also with that comment, Twinkle Twinkie, you win this week's box of mystery hardware. Let's see what's inside. We've got a Hearty Patch is in this week's box. So we've got it's an open source biometric sensor, which you get. We've also got a bunch of very, very delightful enamel pins from Corvo, a pair of Corzo socks, and a pair of Risk 5 socks as well as a bunch of stickers and yada, yada, yada. So drop me your email. Drop me your address and full name in my Twitter DMs. We already know each other, actually. So you can just send me your details and I'll get that sent out to you. Woo.
Congrats.
lots of socks. Who doesn't like technology socks? Everybody loves technology socks.
Yeah.
And in terms of things that are satisfying to design, I know we've only got 10 minutes left, which is outrageous, but I really do not want to let the stream end without talking to you about packaging, because I know you're a packaging nerd as well. So tell me about packaging.
Yeah, well, I fell in love. I fell in love with packaging, to be honest. And actually, it was. In my mind, it's such an underrated discipline, or such an underrated thing to do. How many packages did you open up and just threw away or so? And since I'm doing that, I'm looking very closely at how people are packing stuff. And I bought a laser cutter, the biggest one I could find for the least amount of money. And so I can prototype. I got myself a few cardboards from various thicknesses, like corrugated and just thick cardboard. And it kind of really struck me how easy it is and quick it is to come up with a prototype for a packaging. It's just, I have bought a few books. Let me just share one or two. Like the package design book, which is basically just a reference guide to get some inspiration from. But there's also, that's the coolest book that I have, which is called Structural Packaging. And this one has on every page it has like designs, like finished ones, and you have a CD in there that you can plug into your PC or Mac or whatever you have, and have it printed on the laser cutter.
Oh my goodness, I want
that. And that is so cool that I made.
So it's got the design, and then it's got the finished product as well. And files. My goodness, what's the name of that book again? I'm gonna.
It's called Structural Packaging. That's a gold edition. I'm not sure if that book's sold anymore, to be honest. I bought it on eBay. Yeah, it has all the vector-based templates, and the cool thing is, if you have Fusion 360, you can take that SVG file and make it parametric. So you can change the dimensions, and you can actually use it for your own product. And that's insane. And the cool thing about packaging is you can do so much with just your creativity. If you want to have a cool packaging, chances are it's not going to cost you that much more than a regular box, because it's just more cardboard, right? You can have cool mechanisms and glue spots and whatever. It's not going to be more expensive. You're only limited to your own creativity, basically. And I just use the sheet metal tools in Fusion 360 to just design the packaging. And the first one I did is this year. That's the prototype.
Yeah.
Let me just unfold it real quick. It's the packaging prototype for the SMD magazine rail, because I cannot just use a regular box for it, because it's not square. It's kind of like that triangular shape. If I throw that into a box, it's gonna wobble around all the time. So I made my own design with just a draft angle, or
I see. Yes.
Like how do you call that? Whatever. And so if you insert the rail, it's gonna sit flush.
Oh, that's so satisfactory.
Yeah,
that's satisfactory.
And like and then you have a finished box, right? And how cool is that? Like you only need a laser printer.
Is this the
laser
right?
cutter, sorry.
Yeah, I don't like to link to Amazon, but it was the first one. Is it by Paul Jackson? Is it this one, Structural Packaging? Is this it?
I think that's another book I have.
It's not that one.
Wait, what's the name again?
Paul Jackson?
No, this one here is Joseph. Let me just bring it up again. I can paste the link into the video description.
That would be great. That would be great.
Yeah, sure. Yeah. So that's the one book here. It's Structural Packaging Gold. Structural, yeah. And this one here is Structural Packaging Designs, which is also with the CD and also with the vector based. And you get those here. You have those rip open kind of things.
Oh yeah, I love it.
Just laser out. It's crazy. I thought it's
of course. Yeah.
You could do so many cool things. And
you know what? How are you making for the packaging for this run? Are you going to be lasering all of the boxes, or are you going to start? You're getting a die. No. You're getting a die.
Yes, I am only doing prototypes to test mechanisms and just tinker around. And I'll submit the design to a company which I haven't chosen yet to make the actual, because I cannot do the print design. I can only do black with the laser.
Yeah.
It's not very nice. Also, it doesn't smell very good. It smelled like if I would smoke a pack of cigarettes while packing the stuff.
Yeah, I've lasered a lot of cardboard myself, so I know that
Yeah,
horrible.
yeah.
Yeah,
But
not delicious.
it's really cool to be able to, because now I can take time to make packaging like plastic free. Yeah, you can do so many cool things.
And is the design process and the file the same for a laser cut box as opposed to the die? What files do you have to? What do you have to provide to your box manufacturer? They're just the same, or?
Basically, yes. You can have like there are a lot of standards, and I had a great talk or conversation with a person from England. He runs a packaging company. I saw a video on YouTube and I contacted him because I wanted to learn more about packaging. So I asked him if he would have time to have a call, and he had time, and it was so delightful to have the chat with him. I think we were in a call like 1.5 hours, and I learned so much about packaging, about the standards and about the files and stuff. And it's basically the same file that you send to your manufacturer. I mean, if you don't have like the perfectly correct file, they will transform it into whatever they need. So that's not a big deal. But you can certainly go from your CAD to your laser cutter very easily. And I'm sure that's also the file that the manufacturer wants.
Yeah, really interesting.
Yeah.
Twinkle Twinkie, for those of you who are on the stream who don't know Twinkle Twinkie, he's an iconic badge designer who makes all really amazing PCB art as well. A sommelier of PCB art, I believe, is the description on the Twitter. But he says, I considered using a laser cutter for the clock badge fabric. So at the moment, the DEF CON badge that Twinkle Twinkie's doing is this cute little device, and it's got actual fabric on it as well, which I'm very curious about how you actually managed to do that. But when he nixed that idea, because when looking into laser cutting fabric, I found posts saying how to get burnt smell out of laser cut fabric. It's true, it's horrible.
Yeah.
I will say there's one, I've had success laser cutting felt is the one thing that I have had really good. And that's not smelly, and it's very satisfying actually, and is extremely fast. You just do a very high power, quick pass, and felt doesn't stink to high heavens, but a lot of laser cut materials definitely do.
Oh yeah. But that's interesting to know, because if I do a laser cut here, I just leave my shop and come back 2 hours later, because there's no chance I will survive in here while that's doing its thing. Yes. I don't have any windows here. I just have a ventilation system, which is not enough to stay in the room while this thing is running. So I just have a camera looking at the laser in case it catches fire or so.
Fire, right?
Yeah. But I'm just next door doing whatever CAD or
it's not very
chilling around until it's finished. Yeah.
Talking about CAD, what a useful segue there. So in GitHub, Leon says that you are using Kicad, as they say, Nightly 6. How did you decide to use Kicad, and what's your experience with this new major version? Good question, Leon.
To be honest, I cannot remember the exact reason why I chose to go with the Nightly version. I think there was one library I was using that was only compatible with it, or there was one feature, but I cannot remember which it was that I went with the Nightly. But I chose Kicad or Kicad because actually early on I was using Eagle, and since Autodesk bought it, I don't know, it just kind of went downhill in my mind. I don't like to use it anymore. And the one benefit with Kicad is in Eagle, you always, when you start your schematic, before you make the layout, you start with the schematic, right? You say, okay, connect this pin to that, and then you later on draw the lines. In Eagle, you had to already assign footprints and exact parts and whatever. And in Kicad, you just draw the schematic. You just throw in a resistor. It doesn't care, is it 06, 03, or 402 or whatever. You can decide that later on when you start your actual PCB. And that kind of was the reason why I went away with Eagle and went towards Kicad or Kicad, because it's also free and open source, but it's also a really great tool.
It is. It's come along in leaps and bounds since. I would say, apparently, according to the developers, the Kicad debate, it is Kicad. And the way I remember that is because they are French, and a French person would never say Kai.
Okay, that's interesting.
Kicad.
Kicad. Okay, let's
Yeah,
go with that.
it has come along like in leaps and bounds since I think CERN put a lot of money into Kicad. I think they put a couple of full-time developers onto it, and it massively improved since then.
Yeah,
so
it is. It's a great piece of kit, no doubt.
Yeah,
and it runs on Linux too. Yeah,
exactly, correct. That's
Isn't Fusion 360 also running on Linux? I'm not sure, because Eagle is meanwhile integrated, I think, into Fusion 360.
Leon says also that you're paying attention to all details. It's fantastic. Well done. I fully agree. I actually really love seeing. I think it's really interesting to see more and more people who are making open source hardware projects really start to get into their packaging. You know, like Timon from the Pianura campaign did a cute little packaging thing, but it's also, I don't know if you've seen, I've actually got one on my desk here. Ooh, let me see. So this one was another one from another Crowdsupply campaign from.
It's a fantastic packaging.
Did you see the packaging? Oh my god, it's so nice.
It's ridiculous.
I'll show you.
It is absolutely ridiculous. It's a 10 out of 10.
Yeah, 10 out of 10 packaging. The best packaging on an open source hardware project I've ever seen.
Yeah, look at that.
Look at this.
Look at that.
It's gorgeous.
Yeah, I mean, what do you want? What else do you want? Like this
it's got a deck on it.
Yeah.
You know.
Yeah.
It doesn't, and it's beautiful, isn't that?
It's gorgeous.
Really nice. This is actually injection molded as well. They've went into it.
Those are.
The team are two people, and one of them is an electronic engineer, and the other one's a product designer. So
I'm sure.
This is definitely done by product designers, but it's so wonderful to see open source hardware people start to take a bit more notice of product design as well, because I think that's a sign that we're maturing as a niche industry.
Oh yeah, and that's your first impression. Like you get a product, you open up the packaging, right? That's the first thing you see, and you want to leave an impression, and they certainly do with their.
That's not a box you toss. I thought you were insulting me. I was like, that's British here. I thought you were calling me a tosser. Like, that's not a box you toss. No, it's not a box you toss. There we are. There we go. Yes, it's a beautiful box. I'm very excited, having heard from your about your experiences doing all this laser cutting and then getting the die. I'm very excited to see what you're coming up with as well.
Yeah, that's my next task, actually.
Yeah, I hope you're going to be sharing lots of that on the internet, right?
Absolutely.
Yeah, good. Keep your eyes on Robin's Twitter for exciting packaging design soon. I mean, in fact, I will use this opportunity to pull up your twitter.com.
Yeah, I actually thought about making a YouTube tutorial from scratch to nice packaging, because I think there are a couple of steps involved that I kind of, went through with a lot of effort that are worth compiling into a video. So I might do that after.
That's great. I think that's a really good idea. It's actually something that other people, because if you're an electronics engineer, you're not necessarily aware of how to make packaging, let alone good packaging. So I think that actually would be a really valuable information sharing video for other open hardware designers, or any other designers as well. But that's part of open hardware, really, isn't it? It's sharing the methodology and kind of like trying to move.
Yeah, I mean, basically
forward the vast sum of human knowledge, right?
So
it fits within it.
Basically everything I know is from whatever, YouTube, Twitter.
Yeah.
I haven't studied electronics or product design or whatever. I just look YouTube videos and tear down stuff.
Yeah, definitely.
So it's very important to share.
Yeah, and there's many comments saying please do share. So that's I agree. I will be delighted. I hope you do share that eventually. All right. Well, somewhat improbably, we've already been talking for over an hour now, and we've covered all sorts of exciting things, from board design to the choice of MicroPython. We've talked about packaging and injection molding a lot as well, actually.
Yeah.
So really, really interesting to hear about because I think a lot of people think about hardware design and they just think about the PCB design, but there's so many other aspects to it. Like taking it from like a prototype to a product requires knowledge of many different disciplines. So fascinating to get an insight into what that process has been like for you. Really, really great. And thank you for doing all your learning out in the open as well on Twitter. It's
my pleasure.
inspiring, but it's great for sharing knowledge. Because,
it's my pleasure to share that. It was very nice talking about all those subjects. I could certainly go on for another hour, no problem.
I know, me too.
Yeah.
I often get this at the end of an hour. I'm like, how did that happen? And we've not, I've not asked half of the things I want to ask. Well, we'll just have to have you back on afterwards. So your campaign is currently live. I should put that up there. So it's currently crowdfunding, and so you can go on over there if you want to support Robin's work, either by buying some FD magazines or by buying the awesome Pixel Pump itself. But hopefully, I'd love to have you back on after it's funded, so we can learn more about, because I want to hear updates on how you get from stage to actually shipping, because there is a bunch of work in between there, including packaging. And I would really love to have you back on to
I'd love to. I'd love to come back. It was very nice.
That would be fun, for sure. And as Leon says, time flies. Thank you for the live stream. As usual, it was entertaining and interesting. And yes, Elise, thank you, an awesome product. I fully agree.
Thank you very much. Thank you very much.
I've been really excited watching this come together over it's been like pre-launch for maybe like close to a year, I would say.
Yes. It was. I think it's over a year actually, and it's ridiculous. I was signing up for the project, and you guys accepted it and all that, and then there was like half a year nothing. But I was just developing, I mean, don't forget that I have a 40-hour week day job next to the Pixel Pump. So, and a kid.
And a child. Oh my goodness. How do you do all of this and care about packaging? My goodness. Good for you.
I do not know.
Exhausting. Many congratulations. All right. Well, thank you so much for joining us. I've had a great time chatting with you. It's the first time we've actually met. So, it's nice to make your acquaintance, not just online. Well, I guess this is just online still, but you know what I mean. It's face to face online.
Level 2.
Yeah. We'll have to. I'm sure. I hope to see you at Congress one time. Are you?
I've never attended one. Never.
You've never been to Congress?
Never. 0 times.
Robin, you've got to go. You've got to go.
I really have to, and I want to.
And camp is happening next year. Next summer is camp. You've got to go to camp.
I have to go there. I know.
Compulsory. I
will do that.
It's so fun. And actually, camp, you can take your kid as well. You can't, not for Congress necessarily, but camp is a bit more, there's.
Where is it?
And stuff. So it's, I don't know if they're doing it in the same place, but they have, last time I went to camp, it was, so for those of you that are listening that don't know what I'm talking about, there's a German confederation of hackers, essentially, called the Chaos Computing Club. And they put on these events every year called Congress. Well, not every year, pandemic, yada, yada. But they've been going 39 years now, I think it is. So these are these big hacker events, conferences every year between Christmas and New Year's. But every 4 years, they have a summer camp where you go and you camp in a field with a couple thousand other hackers, and hilarity and hacking ensues. And it's excellent. It's probably my favorite hacker event in the world. And so, it's happening this coming summer. And the last time it was about an hour outside of Berlin. So kind of in the lake, the Brandenburg lakey kind of,
Yeah. That's
area.
Certainly doable.
Yeah.
I should go there. You're right.
Yeah.
So
Congress is a bit more difficult because it's between Christmas and New Year's. If you've got a family, that can be a difficult time to get away from them.
Yeah.
You know what I mean? Not
I know what you mean.
Yeah. But but the camp is a lot more family friendly. But it would be awesome to see you there next year.
Yeah. We'd love to go there.
Yeah, really awesome. All right. We've definitely gone way over. We'll chat again soon, and I hope to see you on the road.
Thanks again for having me.
For joining us, and I will see you again. Actually, next week we will be having a chat with a PCB manufacturer, Screaming Circuits, and we're going to get to have a little look around their factory. So that's happening next week. I loved getting factory tours. It's one of my favorite streaming sessions. I'm like, ooh, fun times. All right, so that's what's happening next week, and I will see some of you there, and I'll see some of you out on the Twitters. Thank you for joining us, and please consider supporting Robin's current crowdfunding campaign.
Thank you very much.
And soon. All right, bye.
Bye.
Bye, everyone.